Today we're going to look at criteria and constraints as we continue working on our design principles. The unit big idea. The engineering design process is a systematic, iterative problem solving method which produces solutions to meet human wants and desires. The lesson big idea. Throughout the design process, designers must constantly compare the solution to the criteria and constraints of the problem. So we're going to be learning today, throughout the design process, designers must constantly compare the solution to the criteria and constraints of the problem. Criteria defined. This was our word of the week. Criteria is the desired elements and features of a product or system. The criteria will show you what the design is supposed to do, what is related to the function, the aesthetics, what color, how large is it. You want to make sure that your aesthetic shows something that's pleasing. It'll be more appealing to people. They'll buy it. It will also look at the efficiency and other things. Constraints defined. This is your upcoming word of the week. Constraints, limitations on a design. Constraints almost involve time, your budget. Your budget can be money. It can also be the number of people. It involves safety, among other constraints. Designers must compare the solution to the criteria and constraints of the problem. So whatever your solution is, it has to meet both your criteria and your constraints of the problem. Remember, the first step of the engineering design process is to define the problem. You go through tests, and the last thing you do is communicate your results. Now here's an example design challenge. For the given design challenge, what would be the criteria and constraints? Excuse me. Challenge. You're going to design an irrigation system that will supply the people in a community in a remote region with a sufficient amount of water. The water tower, with a capacity of 1,000 gallons, should be filled completely in the fastest amount of time without losing water in transportation. Your materials, you're going to use styrofoam, a bowl of water, dowel rods, 4 to 6, straws, a pack, glue. You can use a tin can, scissors, tape is optional, and toothpicks. So we wanted to come up with the design criteria. Now you must transport water to the tower without losing water. You must fill the water tower completely. And it says it's 1,000 gallons. Water tower must fill in the fastest amount of time. That's another one of our criteria. Now, your materials, your water tower capacity of 1,000 gallons, your safety of design, and the time to complete the challenge. So we have discussed the criteria and the constraints. Another thing we look at besides criteria and constraints, trade-offs. When you look at the requirements of a design and you consider the criteria and the constraints and the efficiency, they may sometimes compete with each other. That's when you have trade-offs. A trade-off is a decision process recognizing the need for careful compromises between competing factors. So you're going to say, I'd rather have this than that, such as when you're going in a spaceship. You look at the cost of the material. Some of the things may cost more, or in a car. You may use fiberglass. I think fiberglass is used for Corvettes. They used to be. I don't know if they're still used. But you will look at trade offs like that. The materials that are used will determine the cost. A trade off example: increasing the takeoff power of a spacecraft and using lightweight materials. The increased power results in larger engines, but they're heavier. Newly developed materials may offset weight concerns. We may be looking at something like titanium.